Hello, it's Mr. Answers Guy here. I'm here to answer your question about a spring that you posted about an hour ago. So the first part of the question asks you to solve for the force of tension in the spring, knowing that it has a force constant of 800 newtons per meter and that the spring is stretched by 40 millimeters. So the first part of the question you solve for, which you solve for correctly by saying the force of tension is equal to the force constant times the amount it was stretched, and you converted millimeters to meters correctly and multiplied that by 800 newtons per meter, and you got 32 newtons. So the second part of the question asks you to solve for the mass that must be hung from the spring on Earth in order to have the exact same force of tension as in part A. So if you visualize this in your head, you should get an example like this, where you have a spring that's being hung from a ceiling and a mass that's attached to the other end. What you have to realize about this is that the mass is not accelerating, it is stationary, it's in one spot, and that's because it's balanced by two forces. The force in the upwards direction is the force of tension, which you calculated in part A, and the second force that's being applied on that mass is the gravitational force. So making the assumption that the mass is not moving, you can say that the force of tension is equal to the force of gravity in the downwards direction. And we know from Newton's second law that the force of gravity is equal to, let me just change my font here. The force of gravity is equal to mass times the gravitational acceleration. And in the problem, it's given you g. So if you rearrange for mass, you'll see that mass is equal to force divided by gravity. So in this equation, we do not know the mass. We have been given the g, and the F we can say is our force of tension, since the force of gravity is going to be equal to the force of tension in the upwards direction. So if you quickly plug in those values, you'll get the mass is equal to 32 newtons divided by 9.8 meters per second squared. And that is going to give you roughly 3.3 kilograms. And you'll see in this example that you're dividing newtons by meters per second squared. Since both of those involve the base SI units, you can say with confidence that your answer is going to be in units of kilograms. So I hope that helped you out, and if you enjoyed this answer and if it helped you out, please rate it, thumbs up, give it best answer, and have a good day.